Okay, I'm hoping everybody can hear me now. So my name's Kevin Wadsworth. I'm a Met Office forecaster. I am basically employed by the Met Office to provide weather forecasts. I've been in the Met Office now for quite a number of years. I won't say how many, but it's a long time that I've been forecasting for the Met Office, and it's really nice to be able to talk to you all. I was in the Scouts many years ago. When I was your age, and one of the badges that I did was meteorology, and so that's one of the things actually that got me interested in the weather. I've always been interested in clouds and snow and thunderstorms and all the sort of exciting weather that you get in this country. I don't know if we've got people listening from other countries as well, but I guess we've got people listening from all over the UK, and we get all sorts of different types of weather in this country. And so we need a weather forecasting company like the Met Office who can tell us what kind of weather is coming and help us to prepare for severe weather. So the weather affects us in all sorts of different ways. We need to know what the weather's like if we're going to be flying in aeroplanes, for example. We need to know what the weather's going to be like if we're planning a barbecue or going to the beach, and all sorts of things like sporting events, football, all sorts of big events that take place, gigs, concerts, are all very dependent on the weather and getting a very accurate weather forecast. So that's what we're here for in the Met Office. So how do we put a weather forecast together, and how does it all work? Well, in the Met Office we have our headquarters down in southwest England, and down there they have a very big computer. In fact, it's the one of the largest and most powerful supercomputers in the world at the moment, because being able to forecast the weather needs a lot of very clever computing power. And we have a big computer down there with lots of people, clever scientists, who are sort of working with the information that comes from that computer, and it gives us all the weather forecasts. But how do we program that computer? How do we tell that computer what it needs to know in order to give us an accurate weather forecast? So it starts with, I'm hoping you can all see what I've got on my screen here. It starts with observations, and observations are made in all sorts of different ways. We need to know what the weather's doing at the moment before we can even hope to forecast the weather. So forecasting the weather starts with observations, and we have satellites up in space, and these satellites are sending back information about the clouds and the rain and everything that they can see from space, and feeding all that information back down to Earth, to our computers. The measurements are also taken down on the Earth's surface as well, and we have weather stations dotted all around the country which record the weather. We're recording wind speed, wind direction, temperature, humidity, rainfall, all these sorts of things all the time, and all of this information is really important, because we need to be able to tell the computer what's happening now, and then once it knows what's happening now, it's able to help forecast what's going to happen in an hour's time, or 2 hours time, or 6 hours time, or tomorrow, and further on into the future. So it all starts with having a really accurate picture of what's happening now. And you can make weather recordings and weather measurements at home, even with a thermometer and a homemade rain gauge, for example. You can record your own rainfall in your back garden if you've got one, or at school, or in your scout groups. I'll show you in a moment how to put together a simple rain gauge. We also release weather balloons into the sky, and these weather balloons take measurements, and they send all the recordings back to us, and we're able to take that information and put that into the computers as well. The sun is what causes the weather on this planet. Without the sun, we wouldn't have weather. In fact, we wouldn't be here at all. So the sun gives us all the warmth and all the energy, and that energy from the sun's heat is what creates the clouds, creates the rainfall, creates the wind as well, that blows outside and gives us all of our weather. Without the sun, we wouldn't have any weather at all. So the heat comes from the sun reaching the earth, and the sun is obviously really large compared to the earth, and it produces huge amounts of heat, and that heat arrives from the direction of the sun, and it's most concentrated on the equator. The North Pole and the South Pole, the heat from the sun just kind of skims over the top and pretty much misses that part of the world, which is why the North Pole and the South Pole is particularly cold. They kind of miss out on getting heated up by the sun. So the hottest places on the Earth are right in the middle there. So where that third arrow is, that's where you get the greatest heat, the arrow on the right hand side, right in the middle there, that's where the heat from the sun is most concentrated. So I'm going to stop sharing this screen now if I can. Just bear with me for a second, get this technology to work. There we go, and hopefully you're back just being able to see me. So my name's Kevin Wadsworth. I work at the moment in the north of England as an advisor to civil contingencies. That means that I use my weather forecasting experience to advise the fire service, the police, ambulance, the military, local authorities and voluntary organisations, and it's my job to interpret the weather forecast so that all of those organisations can respond and be prepared when there's severe weather on the way. So it's all about preparing for that kind of severe weather that causes impacts. I mean, it's all very well knowing when the sun's going to shine and when the weather's going to be fine and pleasant, but it's more crucial to get the weather forecast right when we're forecasting things like flooding, severe storms, gales, and the type of weather that can cause damage and cause risk to people's safety. So all of those weather observations that I was just talking about there, and all that ability to forecast the weather is really, really important. And as I mentioned there, you can do a little bit of home weather forecasting yourself and weather observing by setting up a home weather station. Very easy to do. You can either do it at home in your garden or you can do it in your scout groups, and there's plenty of information and advice on how to do that online on the Met Office website. But you can start with something as simple as a plastic bottle like this, and you can turn this into a rain gauge in a matter of just a couple of minutes. I'll show you how to do that. You take your plastic bottle, preferably with a flat bottom. I know a lot of people making rain gauges use things like Coca-Cola bottles or fizzy drinks bottles, but they have a bit of a rounded base to them. So in order to turn this into a rain gauge, you need to make the base flat, which means filling the very bottom of it with something that's going to set hard, some modelling clay or something like that. But if you use a plastic milk carton, the base is flat already. So all you have to do is punch a hole about 2/3 of the way up and then cut around the carton until you've cut it in half. So I'm just going to finish doing that now. There we go. What could possibly go wrong? So you've got the bottom half and the top half. And the important thing when you're making a rain gauge is that the funnel that's going to be collecting the rain has the same surface area, the same size as the container that it's going to put the rainfall into. So in this case, I've used the milk carton, and by turning it upside down, turning the top upside down and putting it inside the bottom, you've got an instant rain gauge, because the top part of it funnels the rain into the rain gauge and the bottom part measures it. And you can see I've put some measurements on the side there. An even better way of doing it would be to put a ruler, a flexible plastic ruler on the side, and glue it onto the side. And then you can, this is marked in centimetres. So if you left this out for a few weeks, you could measure how many centimetres of rainfall had fallen. You can measure it on a daily basis as well. If you make your measurements a little bit finer and you get 5 or 10 millimetres of rainfall, then you can measure 5 or 10 millimetres of rain on there, and you can keep a record. And on average, on the eastern side of the United Kingdom, you'd expect to get about 60 millimetres of rainfall in a month. So that's 6 centimetres in a month. And if you live on the western side of the United Kingdom, then you could probably expect to get about 10 to 15 centimetres of rainfall per month, so up to sort of double that amount of rainfall. So you just need to make sure that there's enough space in your measuring gauge to record that amount of rainfall. And this one here goes up to 12 centimetres, 120 millimetres. So that would be an average of 2 months worth of rainfall for the part of the country where I live. So that's a rain gauge, and you can do take other very simple steps to make your home weather station as well, by putting a thermometer outside. And if you do that, it has to be in the shade, because all of the temperatures that we record are shade temperatures. And you can record the temperature, you can record the rainfall, and then you can even make your own homemade wind measuring devices as well, wind speed measuring devices as well. So you can set up your home weather station and start learning how to observe and forecast the weather. Now, if I can, I'm going to try and share a little video with you, which is about how we make a forecast. So I'll try that right now. And I think hopefully that screen has shared with you. And if I press play, we'll see how this works. Here we go. Okay, so hopefully you saw there how we put a weather forecast together. It's a little video there to give you an idea of just how the Met Office gathers its weather information, puts it all together through that very clever supercomputer that I was talking about, and produces a weather forecast for you. So I know some of you watching this will be in school and sort of thinking about what you might want to do when you get older and what you might want to do for a job and that kind of thing. And I think working as a weather forecaster is an example of one of those jobs that you perhaps might not sort of think about very often. And there's a whole load of jobs that involve working in science and technology, if you're interested in computers, if you're interested in world travel as well, because being a weather forecaster enables you to travel around the country and around the world. For example, I've worked doing broadcasting for BBC television and BBC radio during my career, and I've also travelled out to East Africa to help the African weather services develop their own processes for producing weather warnings. So if you're thinking about in the future, I know some of you are probably a little bit young to be thinking about this now, but if you're thinking about things that you can do when you go on and you leave school and you go to university and those sorts of things, there's a lot of jobs that involve the environment and being outdoors. And I know being a scout, a large part of that is learning practical skills in the great outdoors, hiking, map reading, things like the weather and the world around us. And there's a lot of jobs that are in those kind of industries and those kind of sort of sectors of our economy, and we're crying out for people who have all those sorts of interests. So being in the Scouts and the Explorers and the Cubs is a very good way of developing those skills and finding out whether you have interests in those sort of things. And for me, it certainly sparked my interest in weather forecasting and meteorology. So I hope that sort of helps to inspire you a little bit. One of the things that we need to be able to do in the Met Office, of course, is being able to work out how clouds form and how we identify different types of clouds. You might have looked up at the sky sometimes and thought, wow, you know, those cloud formations are pretty impressive, particularly on a day where we get thunderstorms and those sorts of things. So again, there's a little video here which I'd like to try and share with you if I can. So I will give it another go and see if I can share my screen with you. Okay, let me just see if I can. Here we go. There you go. There's a quick little video there that shows you how we name our clouds in the Met Office, and there's a lot of thought goes into the whole process of cloud naming and how we forecast and how we observe the weather. We have people all around the country at the moment who are recording and observing the weather, writing it down and sending the information to our headquarters. And we also have a lot of amateur weather observers, people like you, who have little home weather stations which you can get very cheaply now on the internet, and you can plug them into your computer and they can send weather information straight to the Met Office, which we use to help make our weather forecasts. So you can get involved in that as well if you want to. It's called WOW, W-O-W, the Weather Observing website, and you can Google that and you can find out how you can make your own weather observations with your own home weather station. And again, that's a good thing to do as a project in a scout group, because you can get together, you can get the little bits of equipment that you need, plug it into a computer and have your weather station and send that information electronically to the Met Office website, and you can have your own weather station that appears on the Met Office website, giving the weather data. We have lots of schools, universities, and scout groups who take part in that sort of thing and send us the sort of information that we need to do our weather forecasts. So you can get involved as much as you like, and if you've got an interest in the weather and you're doing your meteorologist badge, then there's lots and lots of information that you can get both online and in books as well, learning about how to forecast. And as I say, I've been forecasting the weather now for 30 years or more, and one thing I've learned is that no 2 days are the same. It's a really big challenge. Forecasting the future, as you can imagine, is really tough. Sometimes we don't get it right, of course. Predicting the future isn't as easy as we might like it to be, but with these types of computing technology, the types of computers and the computing technology that we have these days, it's really made a massive difference. So the weather forecasting accuracy has improved a lot over recent years, and we're now able to forecast 3 days ahead with the same sort of accuracy that we could forecast just 1 day ahead around about 20 years ago. So we're now being able to see further and further into the future, and the technology helps us with that, and we're learning more and more all the time. So the stuff that you learn at school, the maths, the physics and the science that you learn in your lessons in school, it's being used out here in the real world with people doing these sorts of jobs and doing research, and computer programmers, and all of this stuff that you learn in school is really important, because it's what we use in weather forecasting on a day-to-day basis. Having that information and that knowledge in our minds helps us to understand how the weather works. So when you're doing trigonometry, maybe in maths at school, or you're learning about U-shaped and V-shaped valleys in geography, and glaciation, and the water cycle, and all of these things that you're studying, those are all the building blocks that we use in weather forecasting. And having an understanding of those sort of processes and those things that you learn in school is what enables us to learn more as weather forecasters and meteorologists, and forecast the weather and predict the future. And predicting the future, as I said, is not an easy task. We do the best that we can, and we're quite proud that we do a very good job of it here in the UK. Using some of these techniques that I've shown you and talked to you about this morning helps us do that. So I think that's probably just about reaching the end of my session. I'll show you one more video before I go though, which is if I can find it, about how clouds form. So let me just see if I can find that one for you. Just bear with me a moment, because it's taking me a moment to find it. Just when you need the technology to work, Okay, so hopefully you can see, rather than showing you the video, I'll show you some slides. So hopefully you can see those slides, and I'll just talk through some of those slides for you. So the temperature around the Earth, as I said before, is particularly high around the centre and around the equator. You can see on the map there that the countries that are coloured in red are the ones that get the hottest, and the countries that are coloured in blue are the ones that are coolest in the summer months. And you can see how the heat from the sun heats up the centre of the Earth, or the area, not the centre of the Earth, but the area around the equator. So a quick quiz here. Well, is that a hot or cold country? I think you probably know without me telling you that that's a very hot country. It's Egypt, and that's right in that middle of that zone that I was talking to you about there, where the sun's energy is particularly concentrated. Here's another one here, and some of you may know which country that is. It's Norway. So that's just to the northeast of the United Kingdom, and if you've been to Norway, you will probably know that's quite a cold country. They get a lot of snow in the winter time, and that's because Norway is quite a long way north, quite a long way towards the North Pole there, and the heat energy from the sun is very weak as it hits the north and the south of planet Earth. As I said before, the heat energy is concentrated in that central zone that stretches all the way around the middle, around the equator. Okay, what have we got here? There's a country there coloured in red, which, if you know your geography, is Brazil. And Brazil is quite close to the equator, so it's mostly hot. But it's a big country, and the far south of the country stretches down further towards where we have the colder weather. So it's mostly hot. And that country there, any guesses? I can hear some of you shouting Canada. That's Canada there. And although they do get some nice weather in the summertime, it's mostly quite cold, and they have very long, cold winters in Canada. So this is how the sun heats the Earth. The sun's energy heats the ground. The ground warms and the air rises. And as the air rises, it forms condensation in clouds. And as the condensation in the cloud gets bigger and bigger, and the drops in the cloud get bigger and bigger, they bump into each other and they form water droplets. And those water droplets fall down to the Earth in the form of rainfall, and that's how we get our rainfall. And the warm air rising is a really important thing to understand in weather forecasting, because it's a bit like hot air balloons, where you put the hot air inside a balloon, and as long as the air inside the balloon is warmer than the air around it, it'll keep on rising. And that's how our clouds form. You get bubbles of warm air on a sunny day, and those bubbles of warm air, like those hot air balloons, will keep on rising and keep on rising until they can't rise anymore. And whilst they're rising, you get the condensation. That's what gives us our cloud and our rainfall. So there you go. So when it's cold, we get snow, of course, and it's just the same process as rainfall, except that with the temperatures being lower, instead of it's rain coming out of the cloud, it's snow. And those snowflakes, as you may very well know, every single snowflake is different. There's no two snowflakes are the same. And you can see one there forming on the end of a pin. And that's how a snowflake forms. It needs a little particle of dust in the atmosphere, and then the snowflake and the ice will form on that particle of dust that's floating in the air, or in the cloud, of course. And there's some images of lots of different types of snowflake. Very beautiful, pretty, shows how wonderful nature can be, doesn't it? Storms, of course, are much more serious, and when we get huge clouds, we get thunderstorms. And you get things like lightning from thunderstorms as well, caused by static electricity in the cloud, and that static electricity comes down to the Earth in the form of a lightning strike. And some pretty amazing pictures here of some hailstones. In the United Kingdom, the hailstones don't often get much bigger than peas. You occasionally get one the size of a golf ball, but in the United States of America, they can be as big as your hand. And you can see some of the damage that that can cause on that car bonnet there, which has just been smashed to pieces by the hailstones. Lightning is pretty dramatic, and I don't know about you, but in the summertime I really quite enjoy a nice good thunderstorm, as long as I'm somewhere safe and not out in it. Tornadoes are associated with thunderstorms as well, and that's another form of severe weather. And surprisingly enough, we do actually get a lot of tornadoes in the United Kingdom. So we get hundreds of tornadoes in this country. It's just that they tend to be quite small and not very powerful compared to the ones that you get in America, for example. And I'll just finish there with the storm names that we have When storms get particularly bad in this country, we name our storms, and we've had Storm Kira and Storm Dennis earlier on this year in the United Kingdom, which caused a lot of flooding and caused a lot of damage. So we name our storms so that we can refer back to them in the future and talk about them, and so that it helps to communicate the message when we're telling people that a really bad storm is on the way. And communicating the weather forecast, of course, is a very important part of the job of being a weather forecaster. So there you go. I'll stop there because it's just about bang on 12 o'clock. I've probably talked enough and struggled with the IT for long enough now. But hopefully you've got a little bit of a flavour there of what it's like to be a weather forecaster, how we forecast the weather, and how you can get involved and be an amateur weather forecaster and weather observer yourself.
Kevin,
yeah,
we've had some questions. I wonder whether you'd be able to answer a couple of them for us.
Yeah, of course I can. Yeah, carry on.
So the first question was, how did you get into your career?
Yeah, well, as I sort of touched on there, if you've got an interest in anything like this, whether it's forecasting or whether it's being a park ranger or working outdoors with the Environment Agency, for example, the thing to do is make sure that you study the right subjects. So for me and for weather forecasting, it's things like geography, maths, physics and science. But of course, the Met Office employs a lot of people, so you can also work in IT and technology as well. We have managers, we have people who run the finances and all that kind of stuff. So we employ all sorts of people, but for weather forecasting, it's more the science subjects. So you study the science subjects and go to university and have a nice time at university and get your qualifications. And then you apply to the Met Office for a job. So we advertise regularly, but there are things that you can do to help as well. We have summer placements, so that if you're interested before you go to university or whilst you're actually at university, we do summer placements where students come in and help in the Met Office with certain projects that we have. So by showing an interest and getting involved that way, you can help your chances as well. So I would encourage anybody that's got an interest in weather forecasting to pursue that interest. And if it's anything else to do with the outdoors, then find out what you can online, find out which companies and organisations have the sorts of jobs that you might be interested in, and then just go for it. You know, that's what I did. And having and I'll give you a little tip as well. It's not all about the qualifications. It's not all about how good a degree that you've got. It's about the enthusiasm that you have. So employers these days are very often looking for people who are enthusiastic and have a lot of common sense. So the more enthusiasm and common sense that you have, that'll put you streets ahead of a lot of other people as well. So just a little tip there.
And then the other one, which is quite interesting, certainly up here in Northumberland today, some of us are quite pleased we're not at physical Marra because it is extremely windy up here today. So why is it very windy? Do we know that?
Yeah, we do. It's being caused by a deep area of low pressure, and it's low pressure that causes us strong winds, whether it's in the UK or anywhere else. And it's where the air is rushing up in the atmosphere and it's spinning around and causing this deep area of low pressure. And in the Earth's atmosphere, it's a bit like when you press down on a balloon. The Earth's atmosphere is trying to even out the pressure difference, and that very low pressure to the northwest of Scotland is trying to balance itself out with high pressure that's down over the near continent. So you've got air that's rushing from high pressure to low pressure and trying to balance out that difference in air pressure across the Earth's surface, and that air rushing around is what we feel as wind. So we've got all these strong winds. I mean, I'm speaking to you from Newcastle, so not very far from you in the northeast of England, and we've got strong winds here today, and it's because of all that air is rushing around trying to equalize the pressure and even things out. It's Mother Nature just trying to keep things in balance.
Great. And how many weeks ahead can you actually predict the weather?
We get asked that a lot. So accurately, we can forecast a few days ahead. We can then forecast a few weeks ahead, but not with the same level of detail. It's a bit like looking through thick fog. And when you've got thick fog, you can see objects that aren't too far away. You can see them fairly clearly. Objects that are much further away, you can't really make out very clearly. And it's the same with weather forecasting. We can peer a few hours and a few days into the future and see things quite clearly. But if we're trying to look a few weeks into the future, things are more hazy. So we can give a general idea of what might be coming our way a few weeks into the future, but it's not going to be as accurate as our forecast for this coming week. So for example, we can say that this coming week in England, the weather's going to be fine and settled, the wind is going to go away, and tomorrow is going to be a nice warm day across the country. And as we go through next week, it's going to stay mostly dry with some sunshine and warm weather. But if we're trying to forecast the weather for July and August, we can't do it with the same sort of level of detail. We can tell you that it's likely to be fairly dry and fairly warm, but we don't have the same confidence.
Good. There's quite a few questions just around general cloud formations and why it rains and various things like that. I'm just wondering whether maybe we could answer some of those questions after the chat and just maybe leave the answers in the chat, or certainly post them with the video when we post the video, unless you want to maybe expand on some of those areas.
Well, clouds, we get different types of cloud because of the way that the atmosphere is behaving. If the atmosphere is quite stable, if the air doesn't really want to rise very much, the cloud flattens out and forms a layer, and that's because the air above it is quite heavy and dense, and the rising air goes up and then spreads out because it can't go any higher, and that forms layers of cloud. But on a day where the atmosphere is what we call unstable, the air can just rush up and just keep on going up and up and up and up, and you get these sort of cauliflower or mushroom shaped clouds, and they're the ones that produce heavy showers and heavy thunderstorms. So it's all to do with how stable the atmosphere is and how much the air is able to rise. The more it can rise, the more condensation that can take place, and the more depth there is in the atmosphere for all of these complicated processes to take place. And if you've got great depth where the cloud can form, then that means you can get lots of heavy rain and lots of dark black clouds. But if the atmosphere is quite dry, there's not a lot of moisture in it, and it's quite stable, then you get more blue sky and less cloud. So it's all to do with how much moisture is in the air and how stable or unstable the air is.
That's great. And I think we'll just finish on the last one. What causes the beautiful pink skies we sometimes see?
That's caused by particles in the atmosphere reflecting or refracting the light. So as the sun's light comes towards us from space, it's a white light, and that white light contains all the colours of the rainbow. So when you have a shower or a rain shower, that light is split into all its different colours, and you can see all of the colours: red, orange, yellow, green, blue, indigo and violet. And that's because the raindrops are acting like a prism, and they're splitting the white light into all its different constituent colours. But with a sunset, which appears very red or pink, what's happening is that the particles that are in the atmosphere, usually dust particles, are reflecting all the other colours away, and the only colours that are coming through are the pink and the red colours. So as that sun gets very low in the sky, the white light from the sun is getting broken up, and all of the other colours are being reflected away, but the red and pink colours are being allowed through by the particular particles that are in the atmosphere. And that's why when the sun rises and the sun sets, sometimes you get these very unique colours, which can be yellow, orange, pink, red, purple, all those colours. And it depends on the angle of the sun and the particles that are in the atmosphere, but it's just caused by all the other colours of the light being reflected away and leaving that one colour behind. Clever stuff.
Great, thank you very much.
Okay. Thank you, everybody. I'll say goodbye. Bye-bye, everybody.